Hello and welcome to this edition of EMS Now Up Close. I'm Eric Miskell with EMS Now, and today it's my pleasure once again to speak with Roberto Gatti. He is the CEO of Delvitech. Delvitech is the manufacturer and producer of a sustainable AI-based solution for automated optical inspection. Roberto, it's good to speak to you again. Last time I spoke to you, I believe, was December of last year. So lots has happened between then and now.
Correct. First of all, thank you. My pleasure to see you again.
Very good. Listen, let me ask, yours is, I'm very intrigued by your company and follow it since I was introduced to you guys last year. Yours is a very innovative technology based on artificial intelligence. So tell me kind of the background of that. How did the idea come about, and what are the main features of your specific optical inspection systems?
So basically, the idea came initially when we opened the company. We wanted to differentiate our offer for what was available in the market. Some of our competitors were adding artificial intelligence in the big data management systems, just to better qualify data from that they were getting as an output from their AOI. From my point of view, when we started the company, we said, okay, when you do an inspection of a PCB or above an assembled bulb, you want to see a result and you want to get the best detectability possible in the shortest amount of time. To do so, not typically, but all our competitors were using a classic algorithm, mathematical algorithm with 3D reconstruction with the images. But we all know that mathematical algorithms have limited functionalities. So basically, once you achieved a certain detection, it's very hard to go above it. And the second point is that this way of programming the machine, it's all dependent on the engineer who is working on the machine itself in terms of experience. So what we wanted to do is find a solution that we could bring to the market that was somehow giving the possibility to the operator to obtain a result that was continuously doing better and better. And find a way to have customers not really dependent on the experience of the engineer, but dependent on the way the machine was working. So for this reason, we decided to implement what you call artificial intelligence. In reality, for us, artificial intelligence is not a commodity. Okay, artificial intelligence is a solution completely integrated. Basically, the complete machine is created to work based on AI. The difference in using an AI from a classic mathematical system is the amount of data that you need to treat. If you have a classic optical inspection system that is using just mathematical functions, when you go and you take images inside a certain window, you typically grab 800, 900 megabytes of data that you need to analyze and to classify. When you use AI, you acquire data to build a 3D image, but you also acquire characteristic of image. And this turns out that if you have to acquire data inside the window of 50 millimeters by 50 millimeters, our system acquires up to 80, 90 gigabit of data in 0.2 seconds. Okay? This information needs to be classified, and you need to do a detection in less than another 0.3 seconds. Okay? So the system we created is really high-end in terms of technology, is really innovative, but it's totally integrated on AI. But what I say is that AI here is not something that you can see as a commodity. It's a full integration inside of the system to obtain this result. The reason of this integration is very clear. Every time you install a machine in a line, the customer is willing to get less force calls and higher detectability. A neural network is a system that keeps on learning what's happening in the line. So basically, the systems keeps on learning and keeps on having more and more information, and this more and more information is translated into a better detection. The better detection means less false calls, higher defect rate analysis. So the result at the end of the line is a very high detection and a false cause rate that keeps on decreasing.
That's interesting because I think of it in terms of kind of the evolution of inspection equipment, right? The boards have become denser, the technology is improving that's on the boards, and the equipment to inspect it has to improve and grow with that as well. And so it sounds like the system that you have then is really attuned to, as new technology, new componentry comes into play, whether it be surface mount or even through hole, right? You're able to do, the system is adaptable to all of that.
Yeah, you know, using a neural network, you basically are using something that gets trained. So basically, it's like to put a baby in front of the machine and let this baby learn whatever is happening. This gives you huge amount of advantages. It's not only a better detectability on something that is now very easy to detect, that is SMT and PTH, but you can learn things that are unexpected and impossible to learn for other systems. I mean, if on a board you have a very particular object that is a plastic object, typically you cannot inspect it because it's not something related to electronics. On our machine, you give a look at the component, you learn and you train the neural network, and you will be capable to inspect it. Or, for example, you get metallic parts, screws, or you get glue, transparent glue, whatsoever. Basically, with our machine, you're capable to analyze, learn, and detect what's going on, and create what is a result that gives you a full detection on the board itself. So, just to answer your question, we go beyond what is possible to do right now. And boards are becoming more and more complex. Components are becoming more and more different. You get continuously new shape of components, odd shape components, metallic parts, and so on. And all of this is a headache for an EMS. With this solution, basically, you learn whatever is there, you train whatever is there, and then you inspect whatever is there. With the big advantage that whatever you inspect with one machine, having a neural network shared in the systems can be detected with all the other machines that perhaps are miles away from the one used for the training.
Okay, very good. Thank you for those comments. That's appreciated. You know, one of the things about your equipment too that I find interesting is the industry as a whole, electronics, is characterized by a lot of waste. So can you explain how your technology allows you to help reduce this? I know that's the sustainability aspect is key for you.
Yes, basically, when you use neural network, you get a lot of help in analysis. Okay, so basically, with a neural network checking the characteristic of images, you can detect errors that other systems cannot detect. This helps you to predict the possibility of generation of an error. So basically, when you are in a line and you start to get inspection of components, solder joints that are deviating from their original position, you are capable to understand which type of deviation it is, and you are capable to understand how to make sure this deviation will not happen later on. But all of this is based on training of the neural network. So basically, against a certain problem that is generated, you act like an expert who is checking the line. The expert checks and says, here it's happening that the solder joint is not shaped well because on the screen printer, paste is decreasing, okay? So all of this information are put in a neural network and the machine is reacting like a person, with the big advantage that a person cannot act real time. The machine can act real time and prevent errors to be generated.
Yeah, and that makes sense. And I know that, and that reduces the overall waste, which is what the ultimate goal is then, so.
Yes, the overall waste, you reduce a lot, because at the end of the day, you can save even a small percentage in the automotive industry will let you save millions of components and of PCBs. If you go to other industries where to do checks of specific parts, specific components, you are compelled to destroy the board because you cannot inspect in a different way. With our technology, you can inspect without destroying. So all of this is in any case a sustainability, because you save a lot of materials from being destroyed, because with the classic system, you cannot go there and inspect. With our machine, you can inspect and basically keep the boards, if it's good, as a good product.
Okay, good. So I know sustainability is certainly an issue for the industry, but what are the other kind of challenges that you're facing in the industry?
So there are a lot of challenges, okay? The first one is the fact that customers are willing to inspect things that are totally new and not inspectable for other machines. Okay? So if I have to be totally fair with you, we are doing a lot of business right now. We are going up a lot, but our growth is driven by customers who are asking us, dear Delvitech, are you capable to inspect these specific parts on these boards? Because we have checked with all the other machines and they are not capable to inspect. So this is what is driving our growth. To do this, you need to have a very strong team, but on top of the strong team, you need to have a very well integrated solution in between hardware and software to give the possibility to analyze the problem and to give a result. The big advantage of Delvitech is that we have created a technology. We have not created an AOI. It's a very different thing. We have created a technology that can be deployed in the analysis of an electronic board. But the same technology with some different part of software will be deployed for food analysis. With the different part again will be deployed for pharma analysis. So basically we have an unlimited possibility of inspection. The possibility of inspection is only driven by our business plan. So we say, okay, now we want to go to this market, let's concentrate for this market. But if tomorrow our board will decide that we should go to semiconductor, we have all the solution to go and get a fantastic analysis for semiconductor, all based on AI. And the same will be for fields that are totally different markets, that are totally different, like the mechanical or the plastic markets. We can apply the software and the hardware for that better detectability.
So how, with the system and the technology then, if somebody comes and says, you know, we're having a hard time with this particular component, how quickly are you able to do the analysis and do the adjustments and be able to bring a solution to them?
Typically hours.
Wow.
Typically hours, because basically we have created some very important tools to train the neural networks. And we train these particular neural networks, and the training is quite fast. We just need a very few samples. We do not need 200 boards, 300 boards. Sometimes we use 2, 3, 5 boards to train. And once the training is done, the neural network has learned what is enough to learn. and you can start getting the results and giving the results.
Okay.
So to be honest, it's a different generation of AI.
Yeah. And it sounds like, and that isn't a whole new Delvitech machine they have to buy. Then it's just an upgrade to the system. And if they already have a Delvitech system, they can utilize the existing platform.
So basically, the machine we are deploying is one system, okay, with the same optical head, the same software, the same hardware. There are two different models, one with the head that is moving, one with the head that is stable, okay? But software-wise, technology-wise, they are identical. The customer has a big advantage. They can buy a machine, and they can deploy this machine in every part of their line. So if they want to deploy a machine for post-paste inspection, they take the module and they put in that position. If they wanted to deploy the same machine for pre-reflow inspection, they use the same machine pre-reflow. If they want to go post-reflow, they go post-reflow. If they want to go post-wave, they go post-wave. So for a big industry or for a large manufacturing, the biggest advantage is that they buy one machine with one software. They train the engineer on that software. They train maintenance guy on that hardware. They do spare parts analysis and the stock of spare parts, inventory of spare parts in their location for that machine. And just with one module, it can be deployed in every specific part they need inside their production plant.
Excellent. And I wanted to get to that, so let's just transition to that. The difference between the two machines that you have. I know that you had exhibited at the S&T Nuremberg here with both of the machines. Maybe you've already done a little bit of, but explain the difference between the two machines. It's the Aton and the Horus, right? And maybe differentiate which is appropriate for what.
So let's say that the two machines, as I said, are using identical optical head, and the optical head is with the 6 cameras, with the polarized camera integrated, everything covered by different patents. And the biggest difference is on the Aton machine, the optical head is fixed, the board is moving under the optical head. The advantage of this machine is that the height of the components can be up to 12 centimeters on the board. And basically, you have a very important Z-axis that allows you to have always the component you wanted to inspect in a perfectly focused position. And this machine is perfect for EMS, small EMS. They do not know which type of products is coming in. They don't want to get any limitation. So with this machine, basically, they can inspect everything, really everything. And this machine is a little bit slower than the Horus, but it's a machine that can run pretty fast, but can offer a very good possibility of inspection. The customers who are more interested to this machine are typically those customers producing power electronics or subcontractors or pharma industries. So people who has to produce boards, sometime with a lot of big components or with tall objects that they want to inspect. The other machine, that is the Horus, is same software, same technology of the Atom, but there is a big difference. The optical head is moving. The conveyor could be single lane, dual lane, could be single part or 3 parts, and it's a machine that is extremely fast. So compared to the Atom, the height of the component is limited to 60 millimeters, more or less, but on the other side, the speed is extremely high, and this is the classic machine for people producing mobile phones, people producing CPUs, people producing IoT systems. So where you get the volume, you want to go fast with a very high precision, you use the Horus machine. Mm-hmm. They are both systems have a biggest challenge that you were mentioning before. What are the challenges that the market is facing right now? The biggest challenge is how to give a solution to a customer who has multiple manufacturing plants to be capable to train all the machines together, even if they are in very different plants. How can you guarantee that the quality of a Delvitech machine programmed in Malaysia is the same of the quality of the Delvitech machine programmed in the United States or programmed in Mexico? Mm-hmm. Right now, it's almost impossible for anybody to give this guarantee, because basically the quality of the inspection is related to the quality of the program. And the quality of the program is related to the quality of the engineer and to the experience of the engineer. What we are capable to do with our machines is to use a centralized server. In this centralized server, we do not have the programs. We have the neural networks. We have the libraries. So basically, wherever you want to deploy the machines will use the same neural network trained for everybody. And this neural network will keep on learning in terms of experience for all the different plants. In this way, basically, you are sure that whatever is coming out from a line, in terms of quality, will be identical to the other lines. Of course, this is a big challenge because, as you can imagine, everything is related to hardware and software integration. GPUs, powerful PCs, cables, cameras with FPGA integrated, special software for communication, and very important, neural network. Okay. This is the biggest challenge.
Yeah. You know, as I hear you speaking, I reflecting when I visited some EMS recently, the big challenge that they face, many of them are doing low volume, high mix type manufacturing, which means that there's multiple changeovers on a line every day, right? And the challenge is to get that changeover time lower, right? We've heard very high ranges, but there seemed to be a goal of getting that to under 10 minutes, right? How does the Delvitech equipment, how quickly are you able to do a change of programming with those? Is that very quick, or does that take some practice?
It's extremely quick, very, very quick. Very quick, it's also limited. I would say it's very, very fast. The point is that you are not talking about, again, a mathematical function that you need every time to change. You're talking about a neural network. The neural network gets adapted immediately to a different production. What the neural network learns is how to inspect a component. I just give you an example. In a standard DOI library, you would put information like dimension of the component, color of the component, and this information that are typically related to the dimension of the component itself. In our library, you get everything. So characteristic of the component, dimension of the component, color of the component, how to inspect the component, in which way the neural network should inspect the component to get out the best. So once you have these libraries prepared, it doesn't matter if you're putting board A, board B, or board C. Everything that is related to the inspection is in the library. So the fine-tuning is a very, very fast process, let's say. If you have to do a changeover, if you want to go from board A to board B and they are already prepared, this is a matter of seconds.
Okay. Very good, very good. Yeah, I assume that would be the case for that equipment, but it's always interesting when I was talking to people saying where they were, and everybody's trying to shorten that time because you want the lights green on the line, not red, right? That green means money, so you want that going.
Green means money, and you need to pay attention to the amount of false calls, because sometimes if you go fast, but you have a lot of false calls, you get the green light immediately, but the machine will be a pass-through handling system, okay? Because it will take the board, it will generate 20 false calls, once, twice, 3 times, 4 times. At the 5th time, the operator will simply say, okay, it's a pass-through. We don't check the boards anymore. Too many force cores, no? On our machine, let's say that we are paying a lot of attention to go very fast, but to be very precise. Because otherwise, the two things are not matching. No? If you are too fast, but you get too many force cores, it's not good. You need to be very fast and very precise with the result. Detectability is our goal. And, you know, we are Swiss. So we cannot fight our competition with the price of the machine. We are fighting our competition in an honest way with the performance of the machine. So we wanted to be capable to go to customers and to say, okay, we can do this. It doesn't mean that the other cannot, but you customer evaluate if what we are giving you is really something different. In this moment of time, machine is very different from what you can typically find in the market. I don't say better or worse. I just say it's very different.
Yeah. No, very statesmanlike of you, the way you phrase that, very nicely. So, listen, this has been fantastic. Let me ask though, for people who are seeing this and are interested in learning more, I know they can reach out. There are ways to contact there. But the next, I know that you're exhibiting at Electronica this fall as well, are you not?
Yes, we are exhibiting at the Electronica in Munich, and we are going to be there with all our machines. It will be also quite a big booth. We have already a lot of customers who are willing to come, who are interested. In this moment of time, we are very overrated as a company because we have a lot of requests, a lot of benchmarks going on. So the exhibition in Munich could be a good moment to program a meeting, to see a demo, to understand how the machine works, and to spend a little bit of time not only understanding how the machine works, but understanding how the concept of the machine is, because this is the most important part of the machine to understand and to learn.
Okay. Excellent, excellent. Well, I will be at Electronica, so I'll make a point of coming by and seeing the equipment live as well. So I look forward to that. It's always interesting to see it real after speaking to somebody like yourself. So,
absolutely.
Yeah. So Roberto, thank you for your time today. Thank you for sharing more about Delvitech and its solutions for the industry. Very impressive. And I hope we can catch up and get some updates again in the future.
Absolutely. I look forward having you at our booth in Electronica. Once more, thank you again for this interview, and see you next time.
Very good. Thank you, sir.
Thank you.